foldable, please. And fold it, yes. So you're going to take it like this and fold it in half so that you can read transformation rules. Literally, this was a whole day activity last year as I wrote it in my notebooks. But I decided I didn't want to do that because of the 2 hurricane days. So something good came out of the hurricane. All right, notice what I did is A is orange, A is orange. You don't have to use the same colors I do. I just highlighted it. So I said, oh, B is here, B is here, H is here, H is here, K is here, K is here. Also, I added a number sign above the H because this works with any number. Does anyone 16 or older that wants to donate blood? Sorry, I tried. All right, notice above the parentheses, I will say this about 8,000 times between now and June. If it's in parentheses, it is a liar. And I'll explain what that means in just a minute. All right, let's look at the first tab. I'm an overachiever, so I cut my tabs. You can do it on your own time. All right, if I took a rubber band, if I took a string and put it on the floor and fold it up, what would happen to it? It would get narrower, correct? So I am stretching it, so it's going to be a narrow parabola.
We're going to the cafeteria.
Have fun. No. All right, next. Compress means to push down. So if I took a parabola and I pushed down on it, it would become fatter and wider. So it looked like that. All right, we'll wait for the noisy avid kids to get out of here. All right, if your A term is positive, your parabola is happy. If your A term is negative, your parabola is frowning. But that works with any function. That is a reflection across the x-axis. All right, if we go back to the front, the B term is in parentheses. Anything in parentheses controls left to right. So anything in parentheses is left to right. So if I take this and I take my parabola and I push it in, it's going to be narrower if I push it in from the sides. So a vertical stretch and a horizontal compression are the same thing. So therefore, a vertical compression and a horizontal stretch are the same thing. We barely ever use this tab. Hardly ever in this course will we use this tab. All right, next tab. Horizontal translations. Anything in parentheses is a liar. So what that means is if this is positive, it goes to the left. If it's negative, it goes to the right. Yes, that's exactly what it is. Because if you look right here, x minus h. So yes, you are correct. All right, K is not a liar. If K is positive, it goes up. If K is negative, it goes down. And once again, see how this negative sign is outside my parentheses? That means it flips over the x-axis. If it's in the parentheses, it controls left to right, so it flips over the y-axis. All right, please get out your notebook now. We're going to our notebook. Yep, all I did is highlight the letters to correspond to the letters. Let me zoom out. Liar. All right, ladies and gentlemen, let's talk more right. Transformations of functions. There's air coming out. Finally. So in about 2 hours it'll be cool in here. Hopefully less than that. All right, first thing, function family. Graphs / functions that have the same characteristics. All right, functions and graph that have the same characteristics. All right, time for a new word for you. Parent function. The parent function is transformed to create other members in a family of graphs. All right, our first one is going to be linear. And a linear graph, the most basic linear graph we can have is y equals x. Y equals x. So that has a slope of 1 and crosses through at 0. So that is your parent function. The parent function is the most basic graph you can have. Can I translate that graph so it goes another direction? Yes, I can. I could have it look a bunch of different ways. I'm just going to draw it a little bit differently. So that is in the family function of linear, but it's not a parent function because parent is the most basic. Yes? Another type of graph I can have would be quadratic. So next is quadratic. Which is y equals x squared. And the most basic form of that looks like this. It starts at 0, 0, and it opens up. So that is your parent function of a quadratic, y equals x squared. But I can also have a quadratic that looks like this. It's in the family function of quadratic. It's just not the parent function. We can do a cubic. Y equals x cubed. And in my own personal professional opinion, it looks kind of like a propeller. But I can transform that. I can slide it over and it's still a cubic. It's just not a parent function. And let's do one more. Let's do an absolute value one. And I'm going to write this up here. Y equals the absolute value of x. And hopefully you remember back to an absolute value graph is a V-shaped graph that has a slope of -1 until it hits the origin, and then +1 right of the origin. And then I can transform that one. It's still an absolute value. It's just not at the origin opening up with a slope of 1 or -1. And I'll give you just a moment to catch up. It does feel like it's getting a little cooler in here. All right, example 1. All right, so g of x equals the function x plus 3 squared minus 8. All right, let's look at our foldable, and what it wants to know is how is this graph being transformed? So this is in parentheses, so anything in parentheses controls left to right. But what did I write above mine? That it's a liar. So you would think if it's positive, it's going to the right, but it's not. It's really going to the left. So this graph is going to be left 3. And this is your k value. Your k value controls up and down. It's not a liar, so it's going to be down 8. So left 3, down 8. Not too difficult. All right, this next thing is kind of hard to draw, but I think there's like a 98% chance you'll see it next Wednesday, so I definitely want to go over it. So this is example 2. All right, try and draw this one as neat as possible. So there's my coordinate plane. And because I'm trying to be as accurate as possible, I'm actually going to set, those are different sizes. That's not going to be any good. All right, I'm going to go to 0, 2, put a point. And I'm counting by 2. No. That's fine. I can leave it there. All right, so now I'm going to put a point here. This is going to go this way. I'll highlight it so it's easier to see in just a minute. So just get something like that, please. And like I said, I'll highlight it so it's a little bit easier to see. There we go. Much better. All right, so what it wants us to do is translate this. All right, so this right here is f of x. This is f of x. What it wants us to do is draw g of x. G of x. Yep. The g of x is our new one. We haven't drawn it yet. F x plus 1 minus 4. What does this x plus 1 tell us to do? Our graph has a shift which way? Left 1. So it's going to go left 1. And what does this k value tell us to do? Down 4. So if it was me doing this, I would pick points that are easy to find, like this point right here, and go left 1, down 4. All right, mine's not going to fit on my page. So what I'm going to do is count by 2s, so then it will fit on my page. Life is full of overcoming adversity. So we're at this point here, I'm going to go left 1 and down 4. 1, 2, 3, 4. This point here, I'm going to go left 1, down 1. Go left 1, down 1, 2, 3, 4. This point here, go left 1, 1, 2. Oh, 1, 2, 3, 4. There we go. I'm all over this now. All right, so that's that point there. God bless you. Actually, I had a point wrong, but I can fix this. All right, so every point should be going left 1, down 4. 1, 2, 3, 4. There we go. That's better. This curves into here. This point here, left 1, 1, 2, 3, 4. And it continues down. This point here, left 1, 1, 2, 3, 4. And then it's a straight line going this way. On the quiz, am I going to get out my magnifying glass and make sure you're exactly 100% on every single point? Only at the back table if they keep talking. Doesn't that look like the whole thing was shifted left 1 and down 4? It does. I'm happy with that. You know what's going on. Like I said, I'm 95% sure that is a quiz question. And that was actually example 2. That's example 2, which I wrote right there. Yay me. All right, can I go on? Yes? All right, so now we're going to work on example 3. Yep, we're now on example 3. G of x is the transformation of f of x equals x squared translated down 4 units. And this is exactly like your homework problem. Exactly like you have 6 problems just like this. I'm sorry? Yeah, but I don't think there's room to do it in the workbook, so you're probably going to have to do it on. I put it on Canvas, so you can open it on Canvas. All right, first thing I would do is the actual assignment in the book says graph. So in order to graph, what do we need? A graph. Draw a graph, please. So I am a trained professional, so my graph will probably be better than yours, but do the best you can.
Uh-oh.
Come on.
Is that a stamp? That's cool.
Actually, what's funny is there used to be an Office Depot up where PetSmart is, and they were going out of business, and I got it for like $2. I'm like, I'm a math teacher, I need that. Except for they're closed. All right, so like I said, I am a trained professional, so if yours is not as good as mine, that's quite all right. Also, in order to graph, what else should we have? What kind of table? That's not the exact word, but it is corresponding. It's a function table, right? So what I'm going to do is make a little table over here of x and y. But what is my y value going to equal? It says translated down 4 units. So what's going to happen to my x value? It's going to move down 4 units. So this is x squared minus 4. Because it's down, it's minus 4. There's no parentheses. So is anything telling us to go left or right? No. So I know it has to be on 0, 0. Or on 0 on the x-axis. So I'm going to use 0. How many points should I have for a parabola? Annalise, what do you think? All right, just say a number. 5. Good job. So, and I want to use the middle number and then 2 on each side. So we're going to use 0, 1, and 2. So 2, 1, 0, negative 1, negative 2. I understand it's hard to focus without John in here. The struggle is real. All right, so what I'm going to do is replace this x with 2. So 2 squared minus 4. 2 squared is 4. 4 minus 4 is 0. 1 squared minus 4. 1 squared is 1. 1 minus 4 is negative 3. 0 squared is 0. 0 minus 4 is negative 4. Negative 1 squared minus 4. Negative 1 squared is 1. 1 minus 4 is negative 3. Negative 2 squared minus 4. Negative 2 squared is 4. 4 minus 4 is 0. Elise, do you think that's a coincidence that I have negative 3, 0, 0? No, it's not a coincidence. It's a parabola, so it needs to be the exact same points on both sides of it. Good job. Because it has line symmetry. All right, so let's plot these points. Over 0, down 4. 1, 2, 3, 4. Over 2, up 0. Over 1, down 3. Left 1, down 3. Left 2, up 0. And now draw your lovely parabola. Congratulations.
Oh, wait, no, no.
As long as it looks similar to that, you're fine. All right, this is a check, which means you're going to try this one on your own and then compare it to your neighbors. G of x is the transformation of f of x equals the absolute value of x. And how does this move? This is translated right 2 units. Translated right 2 units. All right, so go ahead and try this, please. And then we will go over it in a few minutes. That's no bueno. I'll get it. All right, please make sure your neighbor has the correct answer as well. And hopefully it looks something like that. I got a little carried away on my left side points. I only really needed 2. So, but doesn't that make sense because it's translated 2 to the right? So what you should have done is use positive 2 and then 2 points on either side. So I should have used 2, 3, and 4. And I could have just used 1, 0, negative 1. I was kind of overachieved on those points there. No. With the heat, I had a brain cramp. Yeah. The minimum, really the minimum you needed was just these 3 points here. Because it's a straight line, and how many points do you need to draw a straight line? 2. So I went a little over and beyond. All right, when you're ready, please turn or for me, I need to turn the paper. So I'm going to do that now. We have 12 minutes left. We have 1 example left, and then we're done, and then you can do your homework. You should be able to finish quite a bit of it in class. If you don't finish it tonight, is it the end of the world? No, because I will accept it up until next Wednesday morning at 7:25. So this is example 4. And this is just like the second half of your assignment. So please draw a graph. All right, my first graph is a parabola that is at the origin, so it's a parent function of it, and I'm trying to be as accurate as I can for you. So let's go. So I'm going to have a point at 0, 0. That's my origin. And this will be given to you for your assignment. You won't have to, for the second half of your assignment, you don't need to draw a graph. You just need to tell me what's going on with the graph. So I need a point at my vertex of my second graph is going to be back 1, 2, 1, 2, 3, 4. Back 2, down 4. Back 2, down 4. 3, 4. And then it goes through the origin. And then it goes through 1, 2, 3, 4. Negative 4, 0. And now just draw a parabola. That goes through those points there. There we go. All right, so what we're doing is use the graph. Use the graph of each translated function to identify H and or K and write its equation. And this is just like 7 through 12 on your homework, just like it. So the first thing I would ask myself is H controls left to right, correct? So how far did it go to the left? It went back 1, 2. So what's my H value? Back 2, negative 2. How far down did it go? 1, 2, 3, 4, negative 4. So can I now write that as an equation? Yes, I can. So g of x equals x. Is it good math to write minus negative 2? No, so 2 negatives equal a positive plus 2, and this is a parabola, so it's going to be squared, and then k means we go down 4. So that's my final answer.